Hi everybody, this is Carl Leopson. This is SERP 590 and I'm going to return to our goofy little sample single case research study to talk today about interobserver reliability and how it's calculated in this case. And then I'm going to help you walk through a couple of the examples in your text because they're a little mind-bending, but I want you to see them because they'll give you additional ideas for how you would do inter-observer reliability in your study. Okay? So if you'll remember in this goofy study, I am using the research question, does providing additional light in a room increase reading rate by a young child? And in this study, during baseline, we have a very dim light in the room, and we ask the child to read a passage from a book, and the dependent variable is words read per minute. And in the intervention, or the B phase, we are turning on bright lights, and then we ask the child to read a passage from a book, and we record the words read per minute. Interobserver reliability, or the reliability portion of this, comes in when someone says, well, how accurately did you really record the words read per minute? And how can I have some really belief in you that you got it right? And one way that we can do that, and to make sure that we don't fall victim to things like bias, like I want the scores to be higher, so I just naturally observe them to be higher, or error, so maybe I just screw up the measurement and I don't realize I get it wrong once or twice. And then there's something called observer drift, where you may be watching a dependent variable like social initiations, and across time, across the 10, 20, 30 observations you do, your view of what a social initiation looks like just starts to drift and change. In all those cases, for bias, error, and drift, it's useful to have an extra person following behind you and observing. So that's what we're going to look at here. And on this particular graph, what you're going to see is that the dependent variable, right, is listed as, or depicted here as the black dots and the connected dots in this line. Okay, the inter-observer agreement is represented by the circles. Treatment integrity, or whether or not the intervention was really implemented during a session, is represented by triangles. So let's go to another page where I can show you more of what a data sheet would look like and what an inter-observer data sheet would look like. So let's say we're collecting data on our silly light study, and I am the observer, the researcher, and for every session I am going to record for the session number, I'm going to record the date, what the condition was, and this is all during baseline. These are all baseline sessions, dim light, and the rate per minute of reading. Okay, and I'm going to have a spot to record inter-observer agreement and a spot to record treatment integrity. However, I only have to record them during about 33% of sessions. In this case, in this piece of research, I decide to record them every other session, so I get it in about 50% of sessions. And then if something happens and somebody doesn't show up one day, and it falls back to 33%, at least it won't fall below 33% during any conditions. So like across baseline, you want at least a third of those sessions to have IOA and treatment integrity. And you want your IOA to be at least 80%, or that there's an agreement between the observers at least an 80% level. So let's look at, in this case, what that means. In this case, I do session 1 and I get 20 rate of 20 words read in a minute, and you can I have that different on the graph, but you can see it here. And then during session 2, I add someone else observing. Okay, so I have Joey, grad student, it comes in and observes every other session, and they observe at the same time I do. They record the date, the lighting, and they record what they see as the words read per minute. And in this case, they get exactly the same score on this that I do. And what you do to get that calculation is you divide, in this case, we're dividing the larger number, the smaller number by the larger number. So 30 divided by 30 times 100, 100%. We go another session without any interobserver agreement, happening, or no observer coming in. We get to session 4. I rate it as 30 words per minute. Joey, grad student, calculates it that the student read 33 words per minute. And if you divide 30 by 33 and times it by 100, you get 91%. So it was 91% overall agreement. Okay. Same thing every other session. So here it's, I recorded at 80 words per minute during an intervention phase of strong light reading, and Joey, grad student, records it at 82 words per minute, and that equates to 98% agreement. Just keep in mind over here that if Joey, grad student, on a session gets a lower count than mine, then we divide Joey, grad student's count by the 80, right? So it's the smaller number over the larger number, okay, times 100. Same thing happened down here. Now down here, we ended up with 75% agreement. That's a problem. You're going to have to explain that session. If something like this happens in interobserver agreement, that is when you stop things and you go, holy smokes, what happened? Am I recording wrong? Am I experiencing observer drift? Was it just an error and I need to recalculate next time? You don't want that to keep on happening. So this is a way to not only prove to everybody that you got things right, but every other session to make sure that things haven't screwed up in some way and get things back on track before you ruin your whole study. All of this, studies like this are so hard to set up. You do not want them going down the wrong road. You want to get them back on track as quickly as you can, and that's why you have to bake in these a little bit more complicated situations. Okay? So that's how interobserver agreement would work in our silly light study. Let's take a look at one of the tables in your book that describes some other examples of interobserver agreement. So in this top panel, what they are describing for you or showing you is data collection using a partial interval time-based method, right? So perhaps the behavior is something non-uniform that has some duration, like yelling, okay? And they tend to be happen for 5 seconds at a time, and so you set the intervals up at about 5 seconds. So here you can see that there are, let's see if I can point properly, I probably can't. You can see that across that top row, you can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 boxes. Each one constitutes 5 seconds, so that each one of those rows is a minute. Okay? Or 60 seconds, right? So a minute. So what that means for partial interval recording is if there is a negative in the box, that means no behavior happened at all at any point during that 5 seconds, not any partial part of the interval. Here, if the interval, during this interval, the yelling or behavior started a second into the interval, they show up here, and it continued over into the next interval, and that's why you mark both boxes in a partial interval system. That's different from momentary time sampling, at which you'd only check at the end of this time period and mark the box. Okay, but this is partial interval. So here, the behavior started during the second interval, it ended during the third interval, so both boxes are checked as, yeah, but the behavior yelling happened across both. No yelling happened across this one. Did happen across this box. Not this one, not this one. Did across these 3, 4 intervals. It was 16 seconds long, so it happened across all of them, and then ended during that interval, and there was nothing during the next interval. Now that's what the primary observer saw, okay? The secondary observer, in that second box, somehow they missed the yelling. I don't know. They put their fingers in their ears. They walked out of the room. Who knows? Maybe it was something the student said loud and the person doesn't think of it as yelling, but they did notice it happening during the next interval. Or they started late. They just screwed up. They didn't see it here. They didn't see it in this interval. They didn't hear, they did, they didn't, they didn't. For the second observer, okay? So, the thing that gets tricky here, confuses people, is say, well, how many places did they agree? You want to look for how much agreement there was between the two observers. Agreement does not just mean they both saw it. It can also mean they both didn't see it, right? So here, in terms of point-by-point agreement or overall agreement, anytime the two observers say the same thing, that means they agree. So here, in this first case, neither observer saw the behavior. They didn't see the yelling in that 5-second period, so that's an agreement. One of them did, and one of them didn't, so that's a disagreement. Here, they agreed that it happened. They agreed that it didn't happen. Here, they didn't agree. Here, they agreed that it did not happen. They both say it did not happen. They both say it did. They did. It did. Here, they disagree again. And here, they do agree that it didn't happen. So that's overall agreement. There are 9 agreements, and the total number of cases was 12, so it's 75. Aside from just looking at point-by-point agreement or overall agreement in partial interval recording like this, you can also break it down further, and that's what they're showing in these other 2 boxes. In one box, they're showing you how to break it down to look at just the situations where the 2 observers are looking at occurrences. So to what degree do the 2 observers agree on occurrences? And this other box is, to what degree do they seem to get it right when they both don't see the behavior? And in this case, it looks like the 2 observers, okay, the primary and secondary observer, they are better at both seeing non-occurrences, and they're more likely to screw up at observing occurrences of the behavior. So what that's telling the primary observer, the person running the study, is we need to get together on what a behavior looks like. Here's the way they broke it down in these 2. So they looked at just the times they agreed. So let's look at where those are. That's in this 3rd box. They agreed on an occurrence. They agree on occurrence in this box, and this box, and this box. So those are the 4 boxes. That's what represents the 4. The disagreements are the overall disagreements. They disagree here 1, 2, 3 times. So if you look at the disagreements and the times they agreed at an occurrence, that's 57%. The same thing for non-occurrences. So you can see that there were 1, 2, 3, 4, 5 times that the 2 observers agreed that there was no behavior. Great. But there were still 3 times that they disagreed. So what percentage of their agreements were considered disagreements? Okay, or how do they weigh together? So it looks like there's a bigger problem in this case with occurrence agreement, or them agreeing when a behavior happened. Overall, those 75% is just not very good. You'd want to redo this. Okay, I'll leave you to look at the other 2, and if you have a specific question, remember, if you're getting into the discussion section of our post this week and you're having a hard time figuring out how you would do your Interobserver reliability, just reach out. You can reach me by email. You can go ahead and post it in your discussion section, take a shot at it. You know what I'll do is I'll just give you some feedback, give you some advice, and ask you to go at it again, and we will work it out. Okay? So that is the quick roundup on Interobserver agreement. I hope you have a good week, and remember, reach out and contact me if you need help.